All right, so yesterday we have explored the quadratic function. We have started with graphing the parent function of the quadratic, and then we talked about vertical stretch and vertical compression that is affected by the a value that is before the x squared. Now today we're going to look at two different transformations, two other transformations. We're going to talk about vertical translation up and down, right? And then we're going to talk about horizontal translation, which means left and right, okay? So what we talked about yesterday was vertical stretch and vertical compression. Now, what happens, so remember that y equals x squared? Your parent function. So that's the function that we're comparing everything to, okay? So what happens if I have y equals x squared plus something or minus something, okay? So I'm adding something to that. What happens to my graph? This is what we're going to explore right now. So what I want you to do is I want you to get your phones out, take Desmos, open Desmos, and then graph as we start. Always we start with y equals x squared. And then I want you to start to graph the other functions. So x squared plus 2, x squared plus 4. And then we're going to compare what happens to the original function as you're adding or subtracting constants. Okay? So So again, this is the parent function y equals x squared. So the first one's asking me to graph y equals x squared plus 4. So can you guys tell me what happened? What happened to my original function, which is the red function, when I added that 4? What happened to the vertex? It changed, right? It changed from 0, 0 to 0, 0, 4. Okay? So you see that the vertex has changed from 0, 0 to 0, 4. What happened to the actual graph itself? So if I want to explain to someone, if I want to say the original graph has went up, went down, went sideways, what happened to it? So instead of being right here, what happened to the graph? Went up, right? We call that translation, right? But 4 units up in this case, okay? So instead of being here, it actually got translated 4 units up. So that plus 4 right here, that plus 4 right here caused a vertical translation 4 units up. It caused the vertex to change from 0, 0 to 0, 4. What part of the vertex changed, the x part or the y part? The y. The y part of the vertex has changed, right? And the y is a vertical line. You guys agree, right? The y line is a vertical line, right? While the x is the horizontal line. And since the y part has changed, that means I have a vertical translation. Are we okay with that? Now, what do you expect for the second one, which is x squared plus 2? Sorry, I messed up. I put plus 4 first. So if I have y equals x squared plus 2, what do you expect? That's right. So what would be my vertex? 0, 2. You guys got that. So you see that the green one right? The vertex is at 0, 2. So I can say that I have a vertical translation 2 units up. Yeah? Now, the next one is x squared minus 1. What do you expect to happen since I have x squared minus 1? It won't cause the reflection because what causes the reflection is a minus in front of the x squared. So if I had y equals minus x squared, then that causes a reflection. Right? That causes a reflection. But because I have x squared minus 1, then it's going to move down. So instead of starting here, it's going to start at minus 1, and it's going to still open up. Huh? So let's graph that. So what would be my vertex? 0, negative 1, that's right. And we call that vertical translation 1 unit down, okay? Because compared to the previous one, to x squared, it went down. Okay? And then what would be the last one that we've seen, that we have? Y equals x squared minus 3. And for this one, you see that the vertex is now at 0, negative 3. Okay? So if you're going to fill out this table, right? Let's fill out the first one together. So y equals x squared plus 2. What is the value of k? Remember, k is added to the x squared. So what's the value of k here? 2. Which direction was the graph opening? Up. What was my vertex? 0, 2. What's the axis of symmetry? X equals 0, right? It doesn't change the axis of symmetry. It changes my optimal value. Okay? It changes the optimal value. And then it has the same shape as y equals x squared, but it has a vertical translation 2 units up. You'll see me writing vertical translation as VT, right? That represents vertical translation. So I'm gonna fill out this part just because I have a meeting with a teacher. So I'm gonna fill out this part with you, and I'm gonna get you to fill out the table by yourself. Okay? So how does the value of k affect the basic parabola? So if the value of k is greater than 0, the parabola shifts up. If the value of k is less than 0, the parabola shifts down. Remember, it's not a reflection, it's just moving down. The value of k describes the vertical translation of the parabola. It's known as the optimal value, or the y value of the vertex. remember that the k value represents the y value of the vertex. Are we okay with that? So what I need you to do is I need you to fill this out, and I need you to try this. Now, remember, number one, write with pencil just in case. Number two, remember that we know how to graph quadratics by using what pattern? The step pattern, which is what? 1, 3, 5. So you find your vertex, right? By graphing this, you find your vertex. Then from the vertex, you're going to go up 1 over 1, and then up 3 over 1, and then up 5 over 1 to find your other points. Okay? So I'm going to leave you with this. I will be right back.